Automotive engineering is usually a game of compromises. You balance cost against performance and reliability against innovation. But every once in a decade, the spreadsheets are thrown out the window. A group of engineers is given a blank check and a goal that borders on the impossible. What follows isn't just a car, it's a mechanical nervous breakdown. Today, we are looking at the machines that push the world's most brilliant minds to the edge of sanity. We're talking about engines with oval pistons, cars with 3,000 pounds of hydraulic pressure surging through the doors, and a supercar so aerodynamically unstable it terrified the men who designed it. You'll see how a single obsession at Lexus led to a $500 million mistake that birthed a legend, and why a certain German luxury sedan was built to withstand conditions that don't even exist on Earth. By the time we reach number 1, you'll realize that the greatest leap in automotive history didn't come from a lab. It came from a group of engineers who refused to admit they were beaten by the laws of physics. Number 12. The Cadillac V16. In the late 1920s, Cadillac wasn't just a car company, it was the standard of the world. But they had a problem. Packard and Marmon were encroaching on their territory. Cadillac's response wasn't to build a better V8, it was to build something so excessive it seemed like a fever dream. They decided to fuse two 8-cylinder engines into a single 45-degree V16. This wasn't just about power, it was about the total absence of vibration. Engineers spent thousands of hours agonizing over the silence of the machine. They hid all the wiring, polished every surface, and created a cooling system so complex it required its own specialized maintenance schedule. They were building a masterpiece just as the Great Depression was about to pull the rug out from under the global economy. The car was a triumph of engineering ego, but it nearly bankrupted the division before the first one even hit the road. It was the first sign that when engineers stop looking at the math and start looking at the legacy, things get dangerous. And while the V16 was about luxury, our next car was about a futuristic vision that was 30 years ahead of its time. Number 11. The Vector W8. Jerry Wiegert didn't want to build a supercar, he wanted to build a fighter jet for the street. The W8 utilized a semi-aluminum monocoque chassis held together with over 5,000 aerospace-grade rivets. The engine was a twin-turbocharged V8, but the way it was packaged was a nightmare for the assembly team. Everything was experimental. The dashboard was a literal aircraft cockpit with 4 different CRT screens in 1989. Engineers had to figure out how to keep these electronics from melting under the immense feet of the mid-mounted engine. The result was a car that looked like a UFO and cost nearly $500,000. It was so complex that only 22 were ever produced. The engineers had successfully built a jet, but they forgot that jets require a ground crew of 20 people to stay functional. It was a brilliant, chaotic mess that proved you can't just will aerospace tech into a road car without losing your mind. But if you think the W8 was a packaging nightmare, wait until you see the French obsession with fluid. Number 10. The Citroën DS. In 1955, the world saw the DS and thought it had landed from Mars. The engineers at Citroën decided that traditional springs and dampers were for peasants. Instead, they developed a high-pressure hydro-pneumatic system. This system didn't just handle the suspension, it operated the power steering, the brakes, and even the semi-automatic transmission. There was one central pump, and if it failed, the entire car effectively died. The engineers spent years trying to seal these systems, dealing with green blood mineral oil leaks that would ruin the car's internals. They were obsessed with ride quality to the point of insanity, creating a car that literally could drive on 3 wheels. It was a mechanical marvel, but it turned every mechanic in Europe into a stressed-out hydraulic specialist. The DS proved that you could reinvent the wheel, but the cost was a level of complexity that terrified the competition. However, while Citroën was playing with fluids, a Japanese giant was trying to reinvent the internal combustion engine itself. Number 9. The Mazda 787B.
For decades, the automotive world told Mazda that the rotary engine was a dead end. It was inefficient, it leaked, and it lacked torque. Mazda's engineers took that as a personal insult. They didn't just want to make the rotary work, they wanted to win the 24 Hours of Le Mans. The 787B used a 4-rotor R26B engine that screamed at 9,000 RPM. The challenge was heat. Rotary engines generate incredible thermal loads, and the engineers had to develop specialized ceramic apex seals that wouldn't shatter under the pressure. They worked in a perpetual crunch, testing engines until they literally exploded on the stands. In 1991, they finally won, becoming the only rotary-powered car to ever do so. But the effort was so taxing and the engine was so high-strung that the FIA banned the technology shortly after. It was a victory born of pure, stubborn madness. Keep that stubbornness in mind because it's a recurring theme for the car at number 5. Number 8. The Honda NR750. The Honda engineers are known for being sensible, but in the early 90s, they hit a wall. They wanted the power of a V8 in a motorcycle, but racing rules limited them to 4 cylinders. Their solution was so insane it sounds like a prank: oval pistons. By making the pistons oval, they could fit 8 valves per cylinder, essentially creating a faux V8. But how do you seal an oval piston? How do you keep the rings from wearing unevenly? The engineering team went through hundreds of iterations, failing over and over. They had to invent new machining processes just to create the connecting rods. It earned the nickname Never Ready within the company because the development cycles were a black hole of time and money. When they finally released a road version, it cost $50,000 in 1992. It was a masterpiece of because we can, and it left the engineering team completely drained.
Number 7. The Mercedes-Benz 600 Grosser. Mercedes wanted to build the best car in the world, and they decided that electric motors were too loud and unreliable for a luxury flagship. So they chose hydraulics. But not just any hydraulics. The 600 used a 3,000 psi system to operate the windows, the seats, the sunroof, and even the trunk lid. This meant that if you pressed the window button too hard, the window would fly up with enough force to potentially sever a finger. The engineers had to design silent valves and leak-proof seals that could withstand pressures usually reserved for heavy construction equipment. The complexity was staggering. If a single line developed a pinhole leak, the entire interior had to be stripped. It was a triumph of over-engineering that made the car nearly immortal, but it required a level of precision that made the production line feel more like a laboratory. Number 6. The Lancia Delta S4. Group B rally was a lawless era, but the Delta S4 was its most unhinged creation. Lancia's engineers weren't satisfied with a turbocharger or a supercharger. They wanted both. This was twin charging. The supercharger provided low-end grunt, and the turbo took over at high speeds. Coordinating the transition between the two without the engine leaning out and melting was a nightmare. The car was essentially a space frame with a thin fiberglass shell wrapped around a volatile, high-pressure heart. It was so fast, the drivers complained their eyes couldn't keep up with the terrain. The engineers had created a monster that was faster than the human brain could process. It was a mechanical nervous breakdown on wheels, and it eventually led to the end of Group B itself. But while Lancia was trying to go faster, Lexus was about to spend 10 years trying to be perfect. Number 5. The Lexus LFA. This is perhaps the greatest example of an engineer refusing to settle. Lexus spent years developing the LFA using an aluminum chassis. They were almost finished, the car was testing well, and the launch was in sight. Then the chief engineer decided that aluminum was too heavy. He demanded the car be rebuilt from scratch using carbon fiber reinforced polymer. This didn't just delay the car, it required Lexus to build a proprietary circular loom to weave the carbon fiber, a piece of technology that didn't exist in the automotive world. They spent nearly a decade and hundreds of millions of dollars on a car they would only build 500 of, losing money on every single one.
The V10 engine was so high revving that no analog tachometer could keep up with it, forcing them to use a digital display. It was a project that defied every logic of business, driven by a singular obsessive need for perfection. Number 4. The Porsche 959. In the mid-80s, Porsche decided to build the most technologically advanced car in history. The 959 was a rolling computer at a time when most cars still used carburetors. It featured sequential turbocharging, an adjustable suspension, and an intelligent all-wheel drive system that could shift torque based on surface conditions. The engineers were essentially trying to invent the modern supercar 20 years too early. They had to develop run-flat tires and integrated tire pressure monitoring systems, things we take for granted now, but were science fiction in 1986. The complexity was so high that Porsche lost money on every car, even with a price tag of $225,000. It was a car that broke the mold, but it nearly broke the engineers who had to make all those disparate systems talk to each other. Number 3. The Volkswagen Phaeton. This was the pet project of Ferdinand Piëch, the man who demanded the impossible. He gave his engineers a list of 10 parameters the Phaeton had to meet. The most famous was that the car must be able to be driven all day at 186 miles per hour with an exterior temperature of 122 degrees Fahrenheit, while maintaining an interior temperature of exactly 72 degrees. Oh, and the hood couldn't vibrate at those speeds. Engineers pointed out that no one would ever do this. Piëch didn't care. They had to develop a draftless air conditioning system with 28 hidden motors and a specialized glass coating to reject heat. They built a dedicated transparent factory just for this car. It was a masterpiece of engineering spite. It was a Volkswagen that was built better than a Bentley, and the engineers who built it were pushed to satisfy the whims of a man who viewed physics as a mere suggestion. Number 2. The Bugatti Veyron. When the Veyron was announced, the industry laughed. Piëch again promised a car with 1,000 horsepower that could do 250 miles per hour and be driven to the opera. Engineers struggled for years with the thermodynamics. How do you cool a 16-cylinder engine with 4 turbos at full tilt? The answer was 10 radiators and a cooling system that held 15 gallons of coolant. At top speed, the tires would melt in 15 minutes, but that was okay because the fuel would run out in 12. Every single component had to be invented from scratch. The transmission had to handle more torque than a semi-truck, and the brakes had to stop a 2-ton car from 250 miles per hour without catching fire. The Veyron was the ultimate impossible car, a victory of brute force engineering over common sense. But as insane as the Veyron was, it was a guided missile. Our number 1 car was a weapon that even the bravest men were afraid to trigger. Number 1. The Porsche 917. This is the car that nearly broke Porsche. In 1969, the rules for Le Mans changed and Porsche saw a loophole. They decided to build a 5-liter monster, but they only had 10 months to do it. The engineers worked around the clock, creating a flat 12 engine that was essentially 2 911 engines fused together. The chassis was made of thin aluminum tubing, and to save weight, the gearshift knob was made of balsa wood. But when the car first hit the track, it was a disaster. It was aerodynamically dirty, creating lift at high speeds. Drivers reported that at 200 miles per hour, the car would wander across the track as if it were on ice. The engineers were baffled. They had used the best wind tunnel data available, but the car was trying to kill its pilots. The project was so stressful that the lead engineers were under constant fire, and the company's finances were pinned to the car's success. It wasn't until a lucky observation about dead gnats on the bodywork that they discovered the aero flaw that the 917 became the legend we know. They added a short tail, and suddenly the car was glued to the road. The 917 didn't just win, it dominated, and it became the most feared racing car in history. It was a project born of desperation, built with reckless speed, and finalized through a brush with death. It represents the absolute limit of what happens when engineers stop following the rules and start trying to conquer the wind itself. These 12 cars are more than just transport. They are monuments to human obsession. They remind us that progress isn't a straight line. It's a jagged edge of failures, late nights, and the occasional moment of madness. When an engineer loses their mind, the result isn't just a breakdown. Sometimes it's the birth of an icon. The next time you see a car that seems too fast, too quiet, or too complex to exist, remember the people who stood over a drafting table and decided that impossible was just another word for not finished yet. Because in the world of automotive engineering, the most insane ideas are often the ones that change everything.